Well, hello guys, I'm Mr. G with another video for the grade 10 working about vectors and scalar. Last time we learned how to add vectors graphically. We saw one example. This time we're going to solve another activity and then do two other questions. Let's say use the graphical head-to-tail method to determine the resultant force of a rugby player if two players on his team are pushing him toward with a force of 60 Newton and 90 Newton respectively, and two players from the opposite team are pushing him backward with the forces of 165 Newton respectively. So in this case we have two different directions. We have the direction forward and backward, and those are the directions we must keep here. Okay, so let's start by writing the data here. Now we have that the two players are pushing forward and two players are pushing backward. Let's select, for instance, the forward direction as positive. Let's select forward direction as positive. In other words, we have that F1 is equal to positive 60 Newton because it's forward. We have that F2 is equal to positive 90 Newton. We have that F3, let's write it down because we need the scale just now. So F3 is equal to 100 Newton, and we have that F4 is equal to 65 Newton. 165 backward, therefore they are negative there. Now let's look for the scale, and let's do that question right here. Let's look for the scale first. Okay, so what scale is suitable here? We have 10 Newton, we have 60, the smaller the bigger is 10, and we have a 65. I think the best option here remember this is vector notation there, the best option here is to say that 1 centimeter is going to be equivalent to 10 Newton. Okay, that is the scale we are going to select. Remember, it's entirely optional the way or the type of scale you want. Okay, so we're going to do that one, and then if we do let's do it for each of them. So for F1 we have that 1 centimeter is equivalent to 10 Newton. If we have 60, not the other side, 60 Newton, how many centimeters will it be? Remember, this one is cross product here. You get the x here is equal to 6 centimeters. Therefore, this one is going to be 6 centimeters long. Okay, now F2 is 90, guys. If you do the cross product as I just showed you, you will have 9 centimeters. This one is 10 centimeters, and this one is 6.5 centimeters. There we go. So now here, remember, we're going to use each of these blocks that will represent 1 centimeter. Okay, in my case. So let's start by representing the first vector, and we're going to start more or less on this point. So we have to draw 6 centimeters to the right. So this is 1, 2, 3, 4, 5, and 6 centimeters to the right. Okay, so remember, be careful with the head, and because my space is a little bit getting short here, 1, 2, 3, 4, 5, 6, 7, 8, and 9, it's going to give me 9, but I'm going to move it a little bit to the left, like 1 centimeter to the left. There we go. So now if we do that, this one is going to be F1 equal to 60 Newton. That represents F1. Now right on the head of the first vector, remember, right there at that specific point, you are going to start with the second vector. That could be any vector, but let's continue in the order of vector 2. So we have to draw now 9 centimeters still to the right. So it is going to be starting from that point there. It is 1, 2, 3, 4, 5, 6, 7, 8, and 9. There is my second vector. This is F2, and is equal to positive 90 Newton. 90 Newton, let's write the positive at the front, and let's do the same with the 60 here and write the positive at the front. Now here right on the head of this vector, right on the head there, you're going to draw the next vector, which in this case is 100 Newton or 10 centimeters to the left. So starting from here, you go to 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 centimeters. Remember, try to do it straight line, please. This one is F3 and is equal to minus 100 Newton or 100 Newton backward. Right on the head of that vector, you're going to draw the last vector, which is 6,5 Newton. Sorry, 65 Newton or 6,5 centimeters. So we're counting 1, 2, 3, 4, 5, 6 and a half. So there is and a half. Remember to be accurate. 1, 2, 3, 4, 5, 6,5. So there is the last vector we draw, and this one is going to be F. Write it here. Let me reset these numbers, otherwise it's no space. This is F4, and F4 is going to be equal to minus 65 Newton, guys. So now the resultant is from the tail of the first vector we draw, and the first vector we draw is right here, that is F1, to the head of the last vector we draw. Now the last vector we draw, remember, is a comma 5. So that there, from here to there, represent the resultant vector. Now we once more have to go to the scale. This one is 1 centimeters and comma 5. So this is 1,5 centimeters. Guys, you have to go to the scale. Remember, the scale 1 centimeters is equal to 10 Newton. So 1,5 centimeters is how many Newton, and then you multiply it in cross, you will get that x is equal to 15 Newton, and that 15 centimeters, that is the resultant vector. So the resultant vector is equal to 15 Newton. We're looking for the Newton. F resultant is equal to 15 Newton. That is the answer. But now the answer was negative. If you look, it's moving to the back, so it's 15 Newton backward. And we're done with this question. Quite simple. Simple this question. Let's go to do another 2 questions. I have here selected 2 other questions, but all of them are following the same trend. This one is a multiple choice. 4 options are provided as possible answers to the following question. Each question has only one correct answer. Choose the right answer. A point is acted on by 2 forces in equilibrium. So now this point equilibrium is important. The forces have equal magnitude and direction. No, have equal magnitude but opposite direction. That is the correct answer there. Question 1.2. Which of the following contains 2 vectors and 1 scalar? Distance, acceleration, speed. All those are scalar. All are scalars. All are scalars. B. Displacement, velocity, and acceleration. All are vectors. Distance, mass, and speed. All scalars. This displacement, speed, and velocity. Okay, displacement is a vector. Let's write it here. This one is vector. Velocity is vector. But speed is a scalar. This one is a scalar. So the correct answer is D. Okay? Question 1.3. The 2 vectors act on the same point. What should be the angle between them so that the maximum resultant is obtained? Okay, guys, if the force 1 is pointing there, let's say force 1. What is the angle of force 2 so the resultant force is at the maximum direction? And that will happen when the 2 forces are pointing in the same direction. So if they point in the same direction, then the resultant force is the bigger. Because remember, all you have to do here is to add the vector there. So the resultant in this case is longer. So the option is A, which is 0, degree between the two forces? This is a good question there. And then question 2, guys, is another vector addition, graphically vector addition, but in this case they ask you to determine whether the flag will move, and if so, in which direction. This one can be using algebraically addition, and then you can do the graphical head-to-tail method. So we're going to do the algebraically addition, and then the head-to-tail will mark next time. I'll give you time to try and do it by yourself. So to do this one, we have two directions. We have right and we have left. Let's select, this one is question 4.1. Let's select right positive direction. It means that 3 and 4 are positive. This is positive, this is positive, and 1 and 2 are negative forces, guys. So easy. Resultant force is equal to, and then I am going to write the vector addition for each of them, F1, F2, F3, and F4. Note that I did not substitute the signs here because this one is the vector addition, so it's positive everything. When I substitute now, then I'll add the negative and positive. Let's substitute on this side because of the space. F resultant is equal to, and then we have minus 430 plus minus 350 plus 580 plus 600. Guys, easy. So the resultant force is equal to, so we get that the final answer is 400 Newton. It is a positive answer, therefore the resultant force is equal to 400 Newton to the right, because we say right is positive. Guys, this is the answer for that question. Question 4.2, we'll solve it next time. I'll give you a chance to solve the question head to tail, and we'll mark in the next video. Next video, we're going to start with a new topic related to mechanics, but not vectors for now. But thank you for watching. I hope it helped. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.